Right, so that's the quick intro to Grasshopper components, how you find them and how you are able to pull them up, right? So just to review, first place you can look for tools is up here. By the way, I have a lot of different tools that you may not have. Some of them are Bureau specific tools, let's say. That's the company I work for. Some of them are third-party plugins. Kangaroo might be one that you've heard of before, Weaverbird. Lunchbox is a particularly useful one, but you don't need to worry about that. We won't jump into those. To me, it's foolish for me to try and teach you the components. So this is a big difference between me teaching you Rhino and me teaching you Revit or something like that, and me teaching you computation. I can't possibly begin to go through all of the different components up here and teach you what they do, because there's ever increasing amount that get issued all the time. More and more and more are coming out all the time. So I'd never be able to win that battle. What I can do is teach you how to just learn how to use them. So that's why this idea that we've just covered is so important, that we know how to hover over the inputs to understand what they are, hover over the outputs to understand what they are, and understand how to find these components and how to understand what they do. Okay? There's also, just in case you're wondering, there's this little thing at the bottom that sometimes is very useful. It's telling you how long it took for this component to run. If you don't have that, it's under Display, Canvas Widgets, and it's Profiler. I like to keep that on because when you start getting more advanced scripts, it starts to become something that potentially you need to worry about how fast the script can run and how efficient computationally the script is. So like I said, if we were people who said, hey, listen, I'll use the double-click method to find tools. And we know that one of the first things we want to try is just to make a line. I would type in line, and some people would go, okay, it's the first thing that pops up, this line one, and this one makes sense. Again, it doesn't look like this other guy. He still has an input, this little nub here, and he still has an output. But if I hover over him, again, hovering being a very important thing, this guy says, contains a collection of line segments, if you guys can read that. If you guys all do that. It's a typo, actually. So don't forget that Grasshopper is a beta-free thing. Is it the same for you? No. Okay. Contains. So mine is old, so they fixed it in the new version if you have Rhino 6. But this is the kind of thing that you'll notice is you have to be responsible enough to kind of read between the lines on some of this. So this contains a collection of line segments. So this guy right here does not create, he does not delete, he doesn't modify lines, he just holds them. And this can be a very useful thing because sometimes you need something like this. So for instance, if you were a person who said, I want to create a line in Rhino. So if you just create a line in Rhino. Okay, I've created a line in Rhino. Remember that this guy here and this guy here are connected. They live with each other, right? So if I ever have a situation where I want to create a line over here and I want to get it over into Grasshopper, I can take one of these guys who just contain information. So all of these right here, they contain information. One of them might contain a point, one of them might contain a line. So if I right-click these guys, if you say, see, set one line or set multiple lines, right? As I set one line, oh, and he's like letting me draw. He already put me into that. And now you can see there's another line here. But this is a very important lesson in Grasshopper. Do you see how if you try and do this on your computer and you try and select that line, nothing happens. The original line that I drew, if I select it, one curve added to selection, right? So try that out. Try drawing a line. So the line component is this one right here. And if you draw a line in Rhino, and then you try and if you reference in a line, so you say set one line here, he doesn't let you grab anything, but he will let you draw another one. But that one right there does not exist in Rhino, actually. If I hover here, it says it contains a line that is 11.7 meters long. So there is a line here, but he doesn't actually exist in Rhino. And if you notice, if I click him, he turns green. And if I click off him, he turns red. See how that works? Green, red, green, red. A little bit weird because of our screen color. So this is the next most important thing. first and most important thing is to understand how to find these tools and how to use them, okay, which comes down to hovering, right? So hovering is very important. But the second most important thing, I think, is to be able to use these two buttons up here. This red button and this green button, okay? So if I delete everything up here, I still have one line. And if I turn on the green mode, so I call this green mode and red mode. So if I turn off green mode, I see the red line. If I turn off green mode, the line disappears, but if I click this, I will see it. So in green mode, the only thing that you see are the things that you have clicked. Okay? This is ultra important because Grasshopper is there for you guys, especially architects. You guys want to be inspired by seeing some geometry, right? Again, you'll have an idea. That's more important than anything, that you come up on paper with an idea. Then you'll use Grasshopper to quickly script it. This mode right here will allow you to see not only the final product, but it will help you see sort of how you got there. A lot of computer programming, all computer programming is about, is learning how to make the computer do what you want. So this tool is very important because right now I can actually let the computer tell me, Mr. Computer, did we get it right? In this case, if that's the picture I want to see at this point in the script, then I'm good. If not, I can try and figure out why the computer's not working. So if I wanted to, for instance, do the same thing with a point, say set one point, do you see how now I'll turn off my gumball? I think the gumball is going to confuse things here. So if you have that little arrow system, you can turn off gumball down here. Very useful tool, by the way. If I click it again, no, never mind. Because Grasshopper just automatically allows you to sort of take that point now. You see, if I hover, it tells me the coordinates, and if I click him, I'm able to change it just sort of randomly, right? Again, if I turn on red mode, everything that's on the canvas in Grasshopper is visible, except one more caveat. So if I click any of these guys and I hit my middle mouse wheel, so if I click down like this, this is a very useful menu. So I don't know what it's like if you're using your trackpad, but you shouldn't be using your trackpad. Yeah, middle mouse wheel down. Does everybody have that up on their screen now? Very useful tools in here. One of them is this guy with the blindfold on. And the blindfold disables preview for the selected objects. So if I click that guy, now, even though I'm in red mode, do you see how the gray, it's a different shade of gray, the line versus the point. So I can only see the point in red because line has been turned off. So these are basic things. Don't worry yet, we'll get into why you would do this. But these are the ways that you show what's in Grasshopper via Rhino. So these two buttons are very important, and also the shade of the gray. So these are light gray, and if I do this, it turns dark gray, and you don't see it. Okay? Grasshopper is linked to Rhino. Rhino is there to show you pretty images. So that's one of the main things. You should never, I don't ever see a reason that you should only ever have Grasshopper up. You should, most of the time, especially in an office setting, you have two screens. So you can always see from Grasshopper, because this doesn't mean anything to you. Again, remember the quote about seeing the world through a straw, right? What does that mean? It doesn't look like anything. It doesn't look like your stadium. So that's the main thing right there, is we need to understand where to find the components and then also how to visualize what you're doing on the canvas. Any questions on that?
Of the red black 10 ms and 100%.
10.
This one?
10 seconds, the bottom one, 100%.
Oh, so what this means is actually, this took 10 milliseconds. When I put it down, it still did some calculations.
Oh,
it took time. Takes 10 milliseconds, and the entire script, this represents 100% of the script.
There's nothing related to the object and create.
It does, because it said, well, I mean, it didn't create an object yet because we didn't give it inputs. But when we actually create the objects, you'll see, and when you get more complex scripts, this will get a bigger number, bigger. Because sometimes you might want to do stuff that's very quick, but you wasted a lot of computational resource, so it might take you 3 seconds every time you do something. We'll get into that. I just didn't want you to be confused on this. Don't worry about that right now. So we're all clear. We find tools up here. We can Baidu search down here, okay? So if anybody was saying, I want to draw a circle, right? Again, now we know. Black hexagon emoji. You guys know what I mean when I say that, right? Emoji. It's like on your phone, right? On WeChat. This guy is telling us he just contains a circle. So a circle must be created using another one of these, right? And in this case, I'd pull up circle. Again, I'm not going to teach you all these components, but I will tell you now you should know if I put this guy out here, again, let's do that again real slowly here. So if I do circle, circle, you know that you want a circle. You know that this guy right here, circle, won't be what makes a circle for you. Maybe if you had a circle out here, let's just do that. If I create a circle here, I say set one circle. Again, he doesn't actually even let you create grab a circle that's been created. He wants you to create a brand new one, right? So he really is just, he lives to hold circles. In this case, if I went to the actual circle that maybe makes me something, this guy create a circle defined by a base plane and a radius. If that didn't tell you enough, by the way, hello, did you guys see what just happened?
Yeah.
By the way, I'm going to suggest everybody goes to green mode right now. So everybody click this button. Because while we're hacking and doing basic stuff, it's nice to just be able to see only what you want to see just by clicking it. So in this case, if I delete the green, the red circle out here. So if I click the canvas, I see nothing. If I click this guy, I see that circle. If I click that guy, I see this circle.
Yeah.
Why do I see this hatch pattern here? Does anybody, if everybody has this up,
Yeah.
can anybody use the lessons that we've just learned to describe what this thing could possibly be, this hatch?
We don't have these kind of 9-second things.
If you want the 9 seconds, actually let's turn that off right now because we don't really need that. That's kind of a, so if you go display, canvas widgets, profiler, make sure that's turned off.
We don't have that one.
Oh, you don't have that?
Yeah, the new one.
The new one doesn't have it. It's not under display. Canvas widgets down at the bottom. Oh, so you don't have it. You have it turned off. That's okay.
Definitely. Where is
It's
it?
a profiler.
A profile. Oh.
Yeah. But don't sweat that stuff. I'm turning it off just so that you guys. The
We
big.
already automatically turn on.
Yeah, it usually isn't on. And especially for a beginner lesson like this, I don't think we need it necessarily. So guys, remember we just talked about 1, 2, and 3, right? Inputs, outputs, and this black area where it tells you what it does, right? So we click on this and we get a picture. So what is this picture of? This picture is of what the computer is generating for us. So it's actually a picture of the output most of the time. In this situation here, you might go, what is this business here? This sort of red and green hatch. And really what that is he's also giving you a preview of one of the inputs, which is the plane in which the circle is being drawn. Because how does this guy work? He says, I create a circle based on a base plane and a radius. So if I look at this, this is the base plane, which has a default value of the world XY. And if I look at this guy, he's a radius and he's a number. If we look at the emojis, again, it says 0.1 in the hexagon, which is trying to tell you it's a number. If we hover over this guy, he's a plane. He looks like a little plane. He's the plane. Just like when I click this guy, he just shows a circle. Because again, all he is a circle. So everybody should be in green mode so that the only thing you see, if you just practice it real quick, is the stuff that when you click on it, it shows up. We've just created some dummy components and some dummy objects, right? So we have a bunch of stuff out there. Is everybody clear on that? Okay, now we can start doing more useful stuff. So, again, we see orange here. You guys know that in orange is always, orange and red are never good in the computer. It always means that something bad's happening or something not so nice. So this guy's orange, and what's he say? So if you ever have orange, you have to click this bubble up here. And he says, input parameter A failed to collect data, input parameter B failed to collect data. So this comes as no surprise. He's saying to us, hey, I can't make you a line unless you give me 2 points, right? Also, I just noticed on someone's screen here, one other thing to notice. Some of you might be saying, why does your component say LN? And some of you have like little other emojis. So if I like to, if you go display draw icons, do you see how that changed from LN to an emoji? I personally think that you shouldn't get used to it being this way. It's up to you. There's sometimes people like this. There's a debate in my office about which one is the better way. But personally, I think the better you get at Grasshopper, the more you'll want this, because this tells you more information than the emoji. But just in case you were wondering why mine looks different than yours, that's why. So this guy is saying to us, hey, I saw it over there, it's okay. This guy's saying to us, hey, I need 2 points, please. Sorry?
What do you think?
So if you go up to display, draw icons.
Draw icon.
Yeah.
Oh.
See how you change that? Even if you want to do draw full names, some people like to do that because then it's ultra clear. I really don't like that one. That one just makes it so big. And your scripts start to become very big. So personally, my preference is like that. But you guys can do whatever works best for you. Okay? So the line component here is asking for 2 points. So let's say, for instance, we started on paper. I'm just going to do a new one here. Let's make a quick line script, right? So we said everything in computation is about starting on paper. We're going to stick with that. Uh-oh. So we have an input. We're going to have an output. Yeah. And effectively, what do we want to do? I'd say the first quintessential script is one of those scripts that you can say, hey, I'm going to make a line out of nothing. And it just goes wonk, wonk, wonk. We can make it different length. Yeah? So in this situation, we know that our input, we know what our output is, but what's our input? As designers, now, we want a line which can have length L, let's say. Ooh, that looks nice. So that's all we know right now, right? We want to just something that goes like this. So how would we define that? It's our responsibility to know what that really means for the computer to be able to do it. So we know that we actually have a component that can draw a line for us, but we know that, for instance, those lines actually need 2 points, right? So we actually have to start thinking backwards. So we know that that's what we want. We know that we have a line component that actually can create that for us, if that's the way we want to define it, right? And we know that that takes in a point A and a point B. But now it's up to us to decide, well, where are those point A's and point B's? How are those things defined? What goes in up here that will make that defined properly? So this is not a lesson that has a right answer. This is the beautiful part about computational design, is that I can't tell you what the right answer is here. It's for your design. So I think everybody right now, think about what you would want to do if your script was just a line that you wanted to rapidly be able to do this with it. Zoom it in, zoom it out, make it longer, make it shorter. Think about that for a second. Try and sketch that out, what you would do here. And it need not actually be using something like this. So if you were going to define a line in space, what were the things that you need to worry about? So if it were me, personally, and I was doing it this way, I would sit here and I'd say, well, I need a point, right? Okay, so what is a point?
Start and end.
Yeah. So those are start and end points, but where are they? I mean, there's
in a space.
They're in a space anywhere, right? So it really comes down to, in our XY coordinate system, right? Does it look like this, right? Does it look like this? It has to be, what are my parameters that will allow me to do what I want to do, right? So let's say, for instance, we constrain our problem to the XY plane, right? Let's just say we wanted anything in the XY plane, and we wanted to be able to create a line, maybe that one just goes horizontally, right? Then maybe, then you have to say, well, is it here or is it here, right? So these are the kind of questions that I couldn't begin to answer for you guys. It'd say, where is it in design space? These are design questions, right? So what I would say is, just as a quick first pass here,
You can have a starting point and then angle and then length.
so that's the other thing. So we are constraining ourselves right now to, if we were saying starting point and an angle and a length, then we'd have to do
Angle.
a little bit of a mathematics to get us sort of the starting point. Let's try it that way, okay? So let's say the input is a starting point. So one of the inputs is a starting point, right? One of the inputs is an angle, and one of the inputs is a length. Okay? So, oops, getting used to the iPad commands here. So guys, here's the question. On paper, you are all architects. Well, you all are architects, so on paper you guys should all know very well how, if I have a point, I have an angle, and I have a length, how can I draw a line between those two things, right? So everybody have a stab at, if this is what I have, again, this is sketching 101, right? I have this guy, right? I have an angle, but relative to what, right? So the angle would have to be relative to some other vector, right? And then I have a length that goes along from here towards here, right?
Mm-hmm.
So how would we do that? Any ideas? This is where it really comes down to the tools. They don't matter. Like if you don't know how to do this, then you have other problems, right? So most people would say it's I need to create effectively, I need to know what this is, right? So first I need to know relative to what am I rotating against.
Mm-hmm.
Second of all, I need to basically know, once I have this vector, then I would be able to do a movement from here to here. That makes sense? It's a very different way of thinking, right? Because if this was AutoCAD or something like that, you wouldn't have to think this way. You'd have a tool and you go click, 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 done, right? In this situation here, let's save this idea. Let's just quickly save that, get that out of the way. And get this out of the way, yeah? So, again, let's take it as a, ooh, cool. I have an X coordinate and a Y coordinate. We have to have something to frame our argument, yeah?
Yeah.
X and Y has to happen. So in this situation, what Williams suggested, I think is a good example. So we have a starting point. So that goes over here. We know we have a starting point. And then we know we're going to need to do something. The last thing that we want to do, if we just described it in English, what are we going to do? Probably an algorithm that does this is figure out what angle, what vector is the angle that we need to be drawing along, what axis should we be drawing on, and then move the point from the first point to the second point, right? So we've figured out this vector in step one, and then we'll move this point from here to here, and then we'll connect the dots, because we need 2 points, right? So step number one would be, one, rotate a vector, right? We'd need to rotate a vector, and we'd have to choose the vector. I think in this case we'd say choose the x-axis. So that step would get theta, and it would get the x-axis. So we already know the input for step one is theta and the x-axis, right? Again, always thinking of input, output. What do we get out of the back of that? We get the vector, yeah? Step two, what is step two? That's a move, okay? And what does the angle just happened, right?
Mm-hmm. Yeah.
Yeah, because now the vector has embedded within it that angle, yeah? So that vector now is going to come down here into the move, because a move needs which direction am I going and what else? How long? So we already have that. Now, do you see what I'm doing here? Because everything's on the canvas, if it's not on this piece of paper, it does not exist. So it's very easy for us right now to sort of sort out our thoughts. If we were to try and do this thinking in Grasshopper, there's a lot of distractions. You know, you're trying to learn Grasshopper, green mode, red mode, all this other stuff. We don't need a tool to help us understand how to do this. This is just first principle geometry, right? So we know that at this stage, at the end of this stage, for instance, we've created this vector, yeah? So at the end of stage 1, we have this. At the end of stage 2, we would have this, right? And then stage 3, which is what? Taking in, this one will create a point, yeah? Yeah, so we're going to create a line, which will take in this point, as well as this point, yeah? Usually it's a lot nicer. You try and make these really nice. We're on an iPad here today. It's a little bit awkward, right? So everybody understand that, right? So if we just show it one more time, and then we go into the canvas, we'll just show it visually. Okay, starting point, step 1, takes in starting point and the x-axis. And what comes out the back is some sort of a vector v, yeah? So this is, we're going to call that a rotate. Step 2 then, this guy comes down here, is a move. And what does it take in? It takes in a point and a vector, and what do we get out? We get a point. I'm showing the point as like X marks the spot, yeah? And number 3 is a line. This guy comes down here, and what does he need? He needs a length, or sorry, I've screwed this up. He needs a point, he needs a vector, and he needs a length, yeah? And then this guy doesn't need a length, he needs the other point, yeah? Clear as mud. And then out the back, what will we get? Not only that, we'll be able, this picture isn't actually correct. Not only this, we'll be able to actually change that, right? So we'll have this very flexible, this will be set in stone, you know, that's the starting point, but we'll actually be able to do something like that. Okay? So very clear 3 steps. So I think I've talked now for 27 minutes in a row. So now I'll give you 5 minutes. You have all the tools that you need to actually jump in and try this problem, okay? So everybody give it at least 5 minutes of trying on your own, and I'll walk around and then I'll collect the issues that everybody's having and we'll go through them, because you all have different issues. There is no right answer.
Just make it 2 point, create 2 point, and then I create a line already.
Yep. So that's the thing is you can create. I've walked around now. Everybody's doing. This is the great part about it. Everybody's different. No one's right. No one's wrong. It's just the question really comes down to if our design, like I said, this is why it's important that someone spoken up and said this is what the design should be. For some reason, who knows why, our design is based off of a start point, an angle, and a length. So yes, we can have lines in many, many different ways. There's an infinite amount of ways to do it. But I see a lot, maybe half of you right now are working on vectors, because that was number 1, as we said, let's play with rotating an x-axis. And some other people have jumped right into lines, right? Doesn't mean it's right or wrong. You can still draw a line that way. But if we wanted to do it this specific way, that would be an important thing to start with, is not playing with the line, but playing with the tool for the rotation. So one piece of advice as you go forward is if you double click the canvas and you say scribble, so SCRBBLE, you'll get something that goes on the canvas like this. If you double click it, you can write in there step 1, rotate.
What's this?
Scribble. So if you double click and say scribble, yeah, scribble, SCR, it'll come up. This is a very useful tool because, again, it's all about thinking ahead of time. So we know there's step 1, 2, 3 here. We've already done that on paper. What's very useful a lot is just to start laying out. So if it were me, I'd say step 1, rotate x-axis. And I'd take this guy, copy. Step 2, let's say it's, what is it? Move, start, point, yeah? Oops.
This is just for ourselves.
For yourself, to frame the problem. Because then it becomes very easy and clean for you to be able to, and step 3 is draw a line. And step 1, before step 1, what did we have? We had inputs, yeah? Input.
How to copy?
Just grab it and Control C. And then Control V. Oh, be careful. William just had this. If you hit Shift and you start, like you can do that type of thing. So you can make your scripts really nice and fancy. But yeah, it's Control C, Control V will get rid of it, get the stuff going. And again, this is an extremely important thing to start with because as an input, we've already discussed what do we want as an input. We want a starting point, we want a length, and we want a theta, right, an angle. So realistically, we have 1 point and 2 numbers, right? So point we already discussed. We know how to create a point, right? I've seen a lot of you doing this. How do we create numbers? Does anybody know how to create a number? Slider, yeah. The slider is the quintessential Grasshopper tool. It's what makes everything look cool, right? If you double click the canvas, let's say that we want the line to be maybe 10 meters long, but we want to be able to change it. So if I type in 10, you see how it says number slider, I press enter. Now I have something that goes from 0 to 10, right? Equally to the theta, makes sense that we would do 360, right? Because we probably want to be able to draw it 0 to 360, right? So if I just type 360.
Slider.
Or you could double click like William's doing right now and say slider and then number slider.
Oh, no.
But the slick, quick way to do it is just type in a number and then it'll pop up. Okay, so normally what I'd do is I'd right click this guy. If you right click him and you say starting point, yeah?
So you can slider. So you can set up what's a parameter. You set 360 or 1000.
Bingo, bingo.
Whatever you want to set up.
So basically, everything that you put up here, you know, we've already made the system that says up here everything is built off of this. So the slider just allows you to quickly change stuff, and everything else will go in place. So this is the basis of parametric design.
That's cool.
You can right click the sliders and give them names. So, length. So a really good script, guys. If you came and wanted an internship in Hong Kong with me, the first thing I'd wanted to see is a nice, clean scripting. It goes a long way. This would be the angle, right? So now there's no doubt this is the way we're starting. Angle, starting point, and length, yeah? And usually what I would do is I'd grab all these things. So if you grab all of them, and again, hit down your middle mouse wheel. And if you go to this green group, you can put all these things together. Nice and clean now. And if I want to grab my starting point, I'll just grab a quick starting point. I don't really care where it is. Just put one out there. We're ready to go. All of this part of the script. Oops. All that's done. Okay, step 1 done. So now it's nice and structured. Step 2, rotate, yeah? So I'm going to get rid of this guy, or maybe I'll just push him down here because I know he's not coming next. Rotate the X, right? So we said we pick x-axis, let's say, as the base axis, yeah? So we said before, how do we find stuff? We can Google it, right?
Why this one is now allow me to change the 360?
So I'll show it for everybody. So he's got a slider up, let's say, that looks like this. And he's trying to double click and go 360, yeah? Some of you probably have this problem as well.
Yeah.
So the way you change a slider is you double click right here, and then you pop it up. You can change if it's a real number or an integer, but also you have a max and min. So I think if you were to do that, you would see that your it looks like your maximum is 1. But really you want it to be 360.
Oh, I see.
And by the way, you probably want it to be an integer and not a real number, because it probably doesn't need to be that accurate. Just keep that in mind when you start sliding the slider. If it's on 3 decimal places accuracy, it's really having to do a lot of work. Every inch across your screen that you move it is thousands and thousands of calculations that it has to try and do.
Yeah. So what's the best way? So you can set up the 360 degree, and then each move will be 1 degree rather than
Yes.
point something.
Yeah. So
what is it?
if it's n, so if you use if you look at what it says here, it says integer numbers or r. So for the integer numbers, you just get 1, 2, 3, 4, 5, 6. Whereas for the r, you're going to get 1,000 values between 1 and 2, basically.
Oh, I see. Then now it's 360. Right. Got it.
Everybody on board with that? Good? So who's found how the x-axis, who knows where we could find the x-axis? We said we're going to pick that as the base. We need some sort of base axis. What's that look like? Where could we look? Who's got an idea of where we could look up here to find the x-axis? Sorry? One of these is the right answer, I promise you. Everything left to display. Which one makes sense? Hint. So the x-axis is a vector, right? So we would expect to be looking somewhere where we have vectors, and this guy's clearly labeled up here as vector. So is everybody able to see that?
Yeah.
Yeah. And then personally, I don't normally do this, but we probably can start looking and just kind of saying, is there anything here that would help us, right? So just kind of looking through and reading. So there's nothing here that comes up. Oh. You guys know what unit means, right? Unit x, right? So unit vector in the x direction. So there is the component that will actually give us the x-axis. Again, if you're someone who likes to do the double click and Baidu searching, you can do x. And look, I just put in x, and the first thing that comes up is unit x. So some of you might be saying, and Emilio said before that in Grasshopper, it's very important to be able to click things and see them, right? So you might click this guy and say, where's the preview of him? The thing is a vector a piece of geometry? A vector is not geometry. A vector is part, so there's no preview, because really, if we zoom in here, it's really just math. It's 1, 0, 0. So some things will not show up. This is very important. Some things will not show up in Grasshopper. They're not geometrical. However, we can display them in Grasshopper using the next most powerful tool, panel. So you can find that up here under the parameters tab, but normally you'll always find yourself grabbing a panel and then dragging something into it. And all he does is he gives you a text-based representation of what's coming out of the output. So I can do that for anything on my canvas. I can do that for the point. Now, who thinks this is weird? If I told you, hey, there's this point in the room, and it's coordinate 7, 5, 7. Like, we don't talk about points in geometry as numbers, right? So you normally wouldn't do this. You would just do this and say, look, there's the picture. We're visual creatures. But for something like this guy, you know, he's a number. We don't see numbers as geometry necessarily, right? And now we can kind of see, if I change the slider, what's going on here. You know? So panel, massively important tool. Okay, so we're on step one. Is everybody kind of, I'll keep the panels around, actually, we might need them. So everybody try and get to kind of the canvas that I have right now. I'll give you a couple minutes, and then I'll walk around and just sort of see where everybody is. So if we all have the same problem, then we can have the same solution.
Where did you get the previous one? I can't know where did you get
This one?
the panel. The panel, I know. The one X.
Oh, x-axis. Yeah, so this one is, if you double click and you were to say X, you don't even have to do x-axis. It comes up right away. Or vector, and just kind of randomly looking through this, and then you find it here.
This is, it just say access.
Yeah. So he's got a great question. How do we find that? I did not know. I should have made this more clear. When I go up here, I don't know where it is. I've used Grasshopper since 2011. Mm-hmm. I don't know that that's exactly where it is. In fact, if we were to play back the video, I thought it was going to be in here. But the problem is it's not something you need to know, right? I know from first principles, x-axis is a vector. So it must be in here somewhere. Worst case, let's see if I have the cheat sheet. I can share this with you guys.
The problem is how so if we have something in our mind, we won't looking for something, and then where to find it. I think because that's the problem. Software is thousands everywhere, some under the menu.
Okay.
You don't know where it is.
So you led me to my next point here. So he's asking the perfect question. Does everybody understand that? There's so many. How can we ever be able to find it? Okay. So let me just, Hong Kong First Principles Education, small modules. So a very special cheat sheet to share with you guys here for Grasshopper. Because the question is perfect. How can I ever be able to understand how to find what I need? So there's a few underlying principles in this cheat sheet that I want to share with you. Go back up. This is Google Translate here for Grasshopper. So I made it. It's mine. No. So 2 key vocabulary words on the screen here. Number 1, if you're saying, I want to create something, don't type into Grasshopper, create something. Construct something. Okay? So if I try and type in, create something, you'll never get anything. If I want to take something apart, so for instance, we've already seen how you could take a number and a plane and create a circle. If I want to take a circle and get a number and a plane, I can send it to you, don't worry about it. If I want to take something apart, you say deconstruct, right? So those are 2 key things. The number 2, and that's important because the main source, now I don't think I'll be able to go there because I don't have internet, but you guys all have internet.
Yeah, we can do it for you. Can you connect to the...
Sure.
The one, yeah, that one, yeah. And then the website, yeah.
I don't know if in Chinese there's a similar saying, but in English there's a saying, give a man a fish, feed a man for a day. teach a man to fish, feed a man for life, right? So it's better to know how to fish because you can always get more fish. Thank you.
Yes.
So in this situation, I can't teach you all the components. What I can teach you is you're not the first person to ever use Grasshopper and to have these problems. And Grasshopper3d.com, I really hope it's okay here. I have a feeling it maybe
Need to.
maybe we have issues. Oh boy, that's a big problem if.
You need to climb the. You need a VPN.
No, never mind. No, we don't. I think that you guys can access this. I'm not on a VPN right now.
Yeah.
This is the Bible. This is where all of the answers are in the most part. But remember this. You have to be specific.
Sdl.com.
Yeah, Grasshopper3d.com. So your best bet when you're starting off is first of all, being able to know someone who knows more than you. So you guys all have your network of friends that can help you.
Yeah.
The other thing is to be able to use Grasshopper3d.com. So for instance, Grasshopper3d.com, you can find all the answers, but you can't type in here, how do I make a line with a start point, theta, and length, right? That's too complex of a search, which is why it's so important for us to break it down like this first, because if we do it this way, we can search how to rotate a vector, right? That might come up. So if we were, or how to find the x-axis. So if we just say construct x-axis, right? Again, language is really important here because if you don't search it, if you guys see that. So construct x-axis. Ooh.
Yeah, it takes time.
It
takes time. Chinese.
It's got it's going to come up with some stuff. Again, there's no guarantee if you're going to have that exact question asked, but this is where you would eventually be able to find it. So the teach a man to fish, while that's coming up, we've not talked about anything specifically. We've talked about how to find things. So kind of going up here and again, randomly sort of investigating, and you actually can read these things and they tell you they're meant for you to be able to figure out very quickly what they do. Double clicking and trying your Google search here, which is an x-axis, which, works very much like Google search, or going to Grasshopper3d.com, right? Which in this case doesn't really come up with anything, but between those three things, you normally should be able to figure it out, right? If we wanted to change the search, actually, we want to create what? Create a vector, right? An x-axis, right? So how do we say create? Construct. Let's just be very generic, not x-axis. This may be too specific. You say construct vector. Again, while that's working, you could go back to Grasshopper and you could say, watch this, construct. Whew, look at all the things that come up. If I say create, I get almost nothing. So keep that in mind. Construct. And in this case, we say vector. I think I saw some of you using this one. Vector. Create a vector by X, Y, Z components. Right? Again, I don't know what this is until I actually use it. So he says I create a vector from X, Y, Z components, but what are X, Y, Z components? And that is just a number X, a number Y, and a number Z. Right? So if we want to create the unit X axis here, what would we do? We would just create 1, and we'd plug it into here. Yeah, into X. And if I want to see that, again, I don't see it in Grasshopper. I can see it here. then you guys see whether I use the unit X component or I use the vector component, it comes out with the same answer. If you want to put in two components into panel, you put in one and then you hit shift and you see how that's got like a plus sign on the wire now. Now there's two. So that is a little bit of background in terms of, again, we're going to do a lot of creation. So that's constructing things. I said if we want to take something apart. So we have this vector. What if I want to take him apart? We said that was deconstruct, right? And look, I said duck, and deconstruct is all that comes up. So these are two really important words because most of the time that's what you're doing. You're creating things and you're taking things apart. And as long as you know what you want to create, the components can guide you to what you should be doing, right? So if I say deconstruct vector, where's my panel? Right, now instead of XYZ in the front part, it's XYZ in the back part, and I have 1, 0, 0. So construct and deconstruct are massively important. In fact, you can actually see it here, that this is the opposite of this guy. In fact, this guy gives you a bit more information because he'll actually calculate the length for you while he's there.
Just one second. Deconstruct. So it basically just display how this construct stuff. I don't quite understand this.
So let's say, for instance, it takes things apart. So most of the, I'll explain it on the board here. This is a good question. How should I do this? Most things, this is a very important concept. Most things have a hierarchy in our industry. So let's say we had a line. Whoa. A line. You guys ever heard of BIM or Revit and stuff like that?
Yes.
This is the fundamental shift in that world, is because everything is organized in its data. So for instance, a line inside of it has a start point, we'll just say point A, and an end point, point B.
Yeah.
And underneath each one of those is an X, is a Y, is a Z, and then the same thing down here, yeah?
Yeah.
So this is the hierarchy, this tree structure, and sometimes you have very elaborate street structures, right? This is a very easy one. If you can think of something like a building, for instance, a building structure would be a lot more complicated.
Yeah.
So when you say deconstruct, what you're actually saying is please, for the line, take it apart and tell me the next level down, let's say, which in this case would be its start point and its end points, right? Then if you said to deconstruct the points, you get X, Y, Z.
Oh.
Oops. So that is, I got too used to duet here. 1 second.
But visually, what is displayed on the drawing
So I show you that in
or
Grasshopper.
on the process?
1 second. So let's take apart this line. So we have a line and a point here. So if we say deconstruct line, right, this is an interesting one. So deconstruct the one, and again, this is why common languages are so important. Deconstruct, if I look, just deconstruct period, is deconstruct a point into its component parts. Whereas everything else is deconstruct date, mesh, face, all these other things, right? So that's kind of misleading because deconstruct point is actually just giving you XYZ, which will not give you a preview. If you wanted to take apart the line, really what you'd have to do is there's another component, and again, this is what comes with time. It's called endpoints. But what's weird about this one, again, now this one would give us a, I just pull up Rhino over here. This one would give us 2 points, right? So we went from the line to points over on the Rhino screen. However, the deconstruct is not so clear. Even, and by the way, you might be tempted to go start point. You don't get anything. Because start point is really with end points, right? So it's just like learning any language. You have to kind of know the little nuances of how they call things. However, again, if we came over to Grasshopper3d.com and we were to search for, again, creating vectors from points, we had talked about this before, angle to vector, that type of thing. If we said line start point, and again, you'd want to search that in just Grasshopper3d.com, then you would probably, you're not the first one who wants that, you'd probably get pointed in the right direction.
What about the other one? The other one you deconstruct. Do we see that
Yep.
visualization?
Let's see, where'd it go?
Yeah, the one, yeah. Can you click that? What do you see?
Point.
This guy right here, the point you see nothing.
Why?
But the point makes sense because the point we know
Oh,
is
X
just
and Y
numbers.
is there.
Yeah.
You can't. Yeah.
But I want to teach you guys something while we're here because this is a good point. No pun intended. All right. So it all makes sense, right, guys? We had the hierarchy of. Just pull it back up here. It's on my other screen now. We had said the line has 2 points, right? But we had said the point A has XYZ. So you might be wondering, is there a way for us to show maybe this information over in Rhino? And the answer is yes, and I think this is one of the most powerful parts of Grasshopper. And this is one that I'm not sure you get taught very often online. This tab right here, the display tab, so if you guys all kind of go up to the top here, display tab, this is where some of the most powerful tools in Grasshopper are. You guys all use Excel, right? You guys have all probably used Excel to create spreadsheets and that do calculations for you. But Excel doesn't do a great, terrific job of showing you why something is the answer. It will just give you the answer, and everything in the background is hidden to you, right? So that is kind of a problem. In Grasshopper, everything can be shown in Rhino. So for instance, if you all just follow along with me here, if we go to dimensions, and they say text tag, yeah?
Text, yeah.
What does this guy do? Represents a list of tags in Rhino viewport. Now that doesn't mean much to me even, and I've used this software for a long time, and I'm a native English speaker. So sometimes these things don't make a whole lot of sense because you don't know what a tag is. It's not a real thing, you know. You think of dog tag, like the thing that your dog wears is what I think when I hear tag, or a price tag. So let's see what he takes and play with him. He says, I take in a location. So location is a point. We can see that by the emoji. So let's just give him a point, okay? And then he says, give me text to display. And I think what I want to do is I want to show the x-axis, x coordinate in Rhino. If I click this guy now, right, and if I just click everybody out here, right, so you can see now I'm able to put text information out into Rhino. Now this is a very simple example, but again, it's this idea that in the Grasshopper medium, you have all these type of data processing tools like Excel, like numbers and text. But just as equally, I could have come out here, if I do // I get a panel, and I just type in some words, right? So // is a very useful shortcut to that. And now I got that text out there. So this can be extremely useful. Equally, you know, if you guys want to do a dimension, for instance.
Oh.
Again, yeah, very, very useful tool if you're someone who wants to quickly show dimensions and stuff like that. And I've done this quite a bit in my career using just that tool. Makes it so much easier as part of your
Oh
job.
my God, you can draw a plan.
Exactly.
No wonder. So literally you can create an object and you're using this tag tool to display each point's coordinates.
Yes, yes.
Oh, okay.
So for instance, if I had there's reasons to do this too. So there might be, you know, reasons that you might want to say this point, I need to show other information next to it, right? I need, you know, in Excel, you might have a bunch of information, A, B, C, D, E, F, G, but they all exist spatially in a different location. This is when this could be very useful. Okay, so that's a bit more on the back half of things here. We went down a little bit of a rabbit hole now on these visualization techniques. Again, these are your best friends once you start getting something that looks a bit more complicated or a bit more developed. If we go back to over here, again, going back to our original script, the idea is that we'd rotate this x vector, let's say x degrees or something like that, right? So you guys should all be pretty expecting now that the main thing we would do here is say rotate. And before we click on the first one, let's see what it says. Rotate an object in a plane. That sounds about right, right? So let's see here. What does he take in? He takes in geometry, yeah? So we put that in there. Then what does he take in? An angle in radians, though. So be careful there, because we're giving it an angle in degrees. So if I'm going to put that in there anyways, but FYI, sometimes if you right-click an input, there's some nice tools in here. And in this case, there's one that converts it to degrees for you. So this is very important, because obviously putting in 360 radians is not nearly as useful in our case as putting in 360 degrees, right? And now I'm seeing a little preview, which kind of looks right given 342. And I can see that actually it's giving me some sort of a point. I don't know why, as a preview. So that's going to be interesting, because actually I've given it a vector, and what's it given me? Everybody see that? This is extremely important. This, every time I teach Grasshopper, I notice stuff like this. So remember before I told you why it's really important to understand literally what goes in here and literally what comes out here? So this guy has asked for what? Geometry. Did I give him geometry? We already asked the question. Is a vector geometry? No, it's math. So what has this guy done for us? Any ideas? Let's do this. So before I saw this and I had this. Now, after I see this and I have this. What's this guy doing here? He represents a point. Where is this point coming from? Did we make a point? No, we had a vector, we had an angle, and this guy said he would rotate the angle. Or did he? He said, I'll rotate a base geometry. And we already said that we didn't have a geometry for him, so we gave him a vector. So he's trying to be clever, and he's converted our XYZ vector into an XYZ point and rotated that point, which is why when I do this now, you're seeing a point, whereas before we've actually converted our information from a vector to a point. This is why when you're getting started, we cannot be sitting here and talking about tools right away. Because this is the principle that's important, that you kind of pay attention and you have a guiding light that says, listen, I don't care what happens at the end of stage 1 here, I want to have a rotated vector, right? Because some of you might be like, oh, I'm done right now, and move on to the next step. But again, the next step said, I want a vector and the original starting point. So right now you don't have that. You have a point and the original inputs. So you haven't finished, and you're not sticking to your plan. So in fact, this is actually maybe not the right tool for us, right? Because we don't actually want it to be geometry. We don't have geometry to rotate. We have a vector. So let's check again. Rotate. And if you look at the emojis, it becomes very apparent. This guy's probably your better bet right here, right? He even says, rotate a vector around an axis. Does that sound better? Again, I can't stress this enough. When you're doing this stuff, these kind of things, they will make it such that you won't get anywhere. You won't learn Grasshopper, and you won't learn design, right? But if you focus on these things first and really understand what the computer wants, he's just doing stuff for you. But you have to speak a little bit of his language. So in this case, I have another thing here that looks very similar, same type of inputs and everything as the other one. But in this case, he says, takes in a vector, rotation axis, okay, we have to worry about what that is, and angle and radians, which we just learned we could do, boom, and degrees, right? But I got to give him an axis, right? So what should be the axis of rotation?
Z.
Yeah. So we learned how before to find the x. So let's see if we get lucky if we say z. Unit z. How you doing? We'll put that in there. Now, let's make it easy. 90. Before I even do this, what should I see come out the back here? If I did my job correctly, the answer's already on the screen. I should see 0, 1, 0, right? Because we should be on the y-axis now, so let's see. Boom. Remember before how I told you there's this amazing point in the room, but it's at coordinate 5, 7, 9, right? We don't think of things that way. Equally, this is I had to go back upstream here and put it in at 90 because we really, when we think of angles, we like to think of 0, 1, 0, 0, 0, 1, 0, right? Negative 1, 0, 0. Remember how I told you this is the magic tab up here? Let's look up here, vector display. If you don't want to do the mental gymnastics of what this actually looks like, why don't we just do vector display? And what does he ask for? He asks for an anchoring point, which I'm going to suggest we use as the starting point, and a vector to preview. In this case, let's look at the vector that we've created. By the way, if you can't find the geometry on your screen, so right now I can't see it in Rhino, again, your favorite friend, the middle mouse wheel, if you click this guy right here, he'll zoom right to what you've selected. Everybody see that? Zoom out again. Hey, I can't see my preview. Middle mouse wheel and click here. And now, if I go and I play with the slider, what's on the right here is nice, but we don't think like that. That's not how we think of vectors. But this picture on the right is perfect for us, and we can actually see that our thing is working. Make sense, guys? Does everybody like that one?
So, literally, all these people, according to what their proposal, they can using these to control the basic roof,
Yes.
the geometry, the beam.
Yes.
I mean, at least like a structure guy. You don't give the thickness first, but you give the line first, right?
Or you could give, for instance, you could give, I know that I have, we could sit here today and we could have a scheme design, and I could tell you, you will have two trusses, these big trusses going this way. You'll have smaller trusses going the other way. And basically, at that point, it's a different problem. You can just sit there and say, well, I can move that around, I can change how many bays I have. You don't need to sit there and have it sized. You'll start like this, and you'll say, hey, listen, let's just first make it such that the layout is automated. The grid lines, for instance, drive the geometry of the structure or something like that on center line. Okay, rotate X, yeah? So we now have the vector that we were looking for in this guy. And what I normally like to do is I like to double click, I like to get a vector bucket, these guys, which just contain information. And I just like to put it right there and maybe label it as, I don't know, line axis, line vector, let's say. That way I know this is my thing right here. And we said before, see if I can find our guy. We had said before that this guy, all we wanted was that guy. So now I'm going to pull up my yellow again, or my red. Okay, we're done. Step 1 is done. So step 2, we had said, was a move of the original point. So now we can start getting faster. So guys, one thing I want to keep in mind, every lesson I've ever done in Grasshopper, and I've done a lot of them, it always works this way. We're an hour and 13 minutes into the session, and we've literally almost done nothing. We've done a lot of first principles and whatnot. We've created a vector and we've displayed it. All right, but now we can start to move a lot faster because now we have the foundation. It'll start to go a bit faster, and that's generally how it works. Is you have to kind of go slow at first, and then it'll start to kick off. So I'm going to take these guys right here. I'm going to group them, and we're done. So I'm going to say the input for the next one, I like to do it this way. The input for the next one was that vector plus a number, right? The number was the length that we wanted it to be, and the starting point, yeah? So let's just copy this guy over. Go back to our thing. Again, he was taking in the length, yeah? He was taking in the vector, yeah? And he was taking in the starting point. We can see that he's coming down here, yeah? So now, and we know that what comes out the back of it, again, just thinking structured, what comes out the back is a point. Right, so even that right there, I'm ready to go. So what comes in the middle here, we had said it's a move, right? So we're going to move this point here along this vector, this numerical length. So this is the length that we had said. Is everybody okay with that? So one might say, what is it that we want to do using English? Move. So we might just say move. And what does he do? First one that comes up. Translate, move an object along a vector. Sounds like the perfect thing for us, right? Sounds like the perfect description of what we need. So we go move, and what does he take in? Again, hovering is your best friend. Hovering helps you out. Move, it says base geometry. So the base geometry's got to be this guy. And the vector, the T is a vector. So already it comes with a default value. And if we look, nothing is changing on my screen, but if I go to a different view, we should see a different... Did everybody see that? Because I had to change my view because it's moving it in the Z direction, right? By default. Now we will be working in the top view because we've kind of constrained our problem to X, Y, right? So the vector that we had from before, if we grab that, again, I don't see both of them, so I'm going to use my fancy tool down here. And, wonk, 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 wonk. Starting to get there now, huh? I know. Anybody see a problem here? No length. Length is not being used. So what do we do? How can we find a tool which allows us to use that vector and that number together? What kind of things could we search, let's say, if we didn't know the answer in here that says what we need to do? Any ideas? Any ideas? So we got a number, we have a vector.
Yeah.
The vector's
the vector need to move along the number, right?
the vector's length needs to be the number. So right now, is the vector's length necessarily the same number as the length that we've specified? So if you guys see here, this length, he didn't go anywhere. He doesn't do anything.
Yeah, we didn't apply it.
Yeah, the vector actually is length 1, right? Because he was unit vector and we just rotated him, right? So in this situation, what I would do if I were you guys personally is I would be on Grasshopper3d and I'd say something like change vector length, maybe. So let's see. So this is a very, again, I could teach you the component, I already know it, but I think it's more important to be able to find it on your own. Because I've used this component 50,000 times, so it's kind of already, I know the language. How does one scale a vector length in Grasshopper? That sounds like a good set of words for us here. Let's see. Hey guys, when you search for something and you find a very simple question like this that matches what you want, and you see this guy's name right here, trust me, it's probably the right answer. He's the one who made Grasshopper, David Rutton, okay?
Oh, really?
So yeah, when you see that, you probably got the right answer, okay? So in this case, it says use the multiply component. If you multiply a vector with a number, you'll scale the vector length. Division also works, okay? So it makes sense. So if we go back to rhinoceros, or in Grasshopper, so he said multiplication, mathematical multiplication. And in this situation, where are we going to put this? We're going to multiply the vector via a length, and we put it in here. And now, all of a sudden, it should be that it's a lot different, at least the length. How do we know if this is correct here on the right? We already covered this. Let's use the computer to tell us if that's correct. So if I do an aligned dimension, he asks for what? Plane, which is we already have XY plane, point A and point B, right? Let's have point A be the starting point B be the ending point, and boom, how you doing? All right, so if I do a couple shift selects here, now we're already cooking because we can change the length and we can change the orientation. Ooh, this is the fun part when you're getting started. This is what I got addicted to circa 2011.
But visually, you don't see the line yet.
Just because I haven't selected it, let's say. Oh, but also because we haven't created it yet. So again, going in order here, we had said the output of this step is a point. We had drawn it as an X here. We've done it. So this part of the script is now done. So if I go here now, that's the point that we wanted. And we can group this, so middle mouse wheel, group. And drum roll please, what did we say is going to go into the final one? 2 points, right? One is the point we just created, and one is the point, the starting point. So this is going to be the easiest step, right? Let's be clean about it. Step 1 is this point. I'm just going to copy this. Step 2 is the point from all the way at the front. Yeah? And then I can just put these in here. And now we've done it. And I'm just going to put them into a bucket for cleanliness. Clean it up. And now that's the line. So the other thing is let's say this was your this was your final script, yeah? So remember we talked before about red and green mode.
Yeah.
So now I'd say if this is your final script, you're done.
Yeah.
I'd grab everything. I'd hit the middle mouse wheel. I'd turn everything off. So now everything's dark gray. Do you see that?
Yeah.
I'd turn on red mode. So now nothing is shown. And I'd turn this guy on. I'd turn him back. This guy. Now, he's the only thing that shows. I don't need to have him clicked. To be honest with you, I'd also turn this guy back on.
Dimension, yeah.
Okay? So that all started here. We understood what we wanted to do, and we got there. I have a spoiler alert for you guys. That's nice. We learned, right? Guess what? There was a way easier way to do this one. Way easier. And as you get better, you'll learn this. So if I said line, again, we said, remember, there's many ways to do these things.
Yeah.
So the first one is, it contains a collection of lines. The second one is create a line between 2 points. This is the one we used. The third one is create a line segment defined by a start point, a vector, and a length. So all of what we just did, the tangent, which is a vector. So all of what we just did, start point, direction, and line, could have probably been made in a completely different way. This is start point and length here, and then the direction would have just been however we want to do it, right?
Yeah.
So even with the script we currently have, we could basically undo effectively most of what we've shown here just by taking in this guy right here. It will give us the same answer, and we wouldn't need all the rest of this necessarily. But I think that's the important point is just look at your options. I'd rather have you guys be able to do this on paper for any problem rather than know off the top of your head, oh, I know that there's a component for this. Because with time, you will learn the components. But if you don't know this, you'll never learn anything. You'll just get frustrated and you'll put it down. And these tools are extremely powerful if you can break down the thoughts like we've talked about today. So this is, in general, I think the way you should script, starting on paper, and then you have mini steps that you, one little chunk at a time. You Google it, you ask your friends, and the longer you do it and the more you dedicate towards it, the faster it will become. So for instance, for your projects, if you have some ideas on how you could automate something so that you could play with different things, why would we do this? Really the question is, why do we do, this script is for learning. So there's not actually a massive amount of a reason why you would need this script. But you should hopefully see that this script could allow you to very quickly do something like, let's say for instance, this was your stadium. So let's do a rectangle in 3D, or in XY plane. And I'm just going to get something called curve here. I'm going to say set one curve. I'm going to grab him. Now he's in Grasshopper. So if I click him, he turns green. It's hard to see because our screen's kind of screwy. But effectively, he says reference polyline curve. That's this guy, yeah? So let's say, for instance, I want to get the area of that guy, and I'm going to tag him, right? So this guy's the centroid, he's going to be the location, and the area is going to be what I tag. So you can already hopefully see that you don't need Grasshopper for everything. On this side of things, if you do points on, normally what I like to do is if I'm sitting here in optioneering, let's say you cared a lot about the area, the occupiable area. You can see here right now and play with this 10 ways to Tuesday, and it's going to be live telling you what the area of your stadium is. Equally, this is a very simple example. You can think of all the different things that you want to know about your design, and it can be made right there for you very quickly. So the script, hopefully, if you have something in your head, the script won't tell you what the metrics are, the numbers that you want for your design. But if you have those, this tool can help you, and then you're sitting here and you're playing with it like it's a piece of clay, and you're saying, you know what would be really interesting? What's the effect of my design if I start doing this to it? And that's really where it becomes, at the stage that you guys are at, not only become very powerful for your designs, but it becomes a very easy learning tool for you. Because you're not trying to do something so complicated. You're just using it as a visualization tool. Any questions on that? Just do a quick lap to see if anybody's stuck. You guys doing okay? No, not okay. So what's wrong with this? That looks right. You can't. You want to show the vector? You want to see this here? So this guy right here. Can you hover right on the V? This guy. See, so he's a vector, right? And here, you've multiplied it so it gets longer, right? But this right here is a point. So what he did was he converted the vector to a point for you. So now you see how you see a point here? That's green. That's not what you want. So you want this vector, right? And you want to use that vector to move somebody, so that goes here. And the start point, where's your start point? Right here. Yeah, so you're almost there. Start point. Yeah? So now that's the move point, and then you can shift.
Grasshopper 把这个给建了。
So now you have the 2 points. 1 point, 2 points. Shift here. Shift. Shift. This guy. This guy. I think that's mouth. I'll show that for everybody else first. So we had someone back here who had a bit of an issue. They almost had it. Maybe some of you are kind of in the same situation. They had the vector multiplied out, and they were putting it into a point bucket like this. So if I copy this guy, Control C. Again, did you see what happened there? No preview because it's a vector, and they'll have a point now because it converted it to a point. So that's not right in terms of what we were trying to do. The other thing is the idea that, remember, all of these things, all of these little boxes, if they're geometry, they can have a preview. So don't forget to try and watch this screen and click around to see what's going on. And if you want to see 2 things at once or 3 things at once, you click something, shift, click something else, right? And you start to see a lot more information popping up, right? So shift, line, point. And that's a very important process, because if you're actually doing that, it becomes a whole lot easier for you to get your head around what's actually going on your script. It basically tells you a visual story of why your script is doing what it's doing. Now you got it. There you go. Yeah, you gotta do, it's in radians. There you go. So how to take that point and actually create, well, the first step was rotate the x-axis, yeah? Oh, hey. Oh, okay, so you're start. Okay, I'm going to show you yours so that you're not doing it. Look, can I show this one and then I'll keep coming down this way. I'll show this because maybe it's the same question. All right, we have another very interesting problem, right? So someone has said, you know what, you were right. There is another component out there. If I double click and say line Sdl, right? We talked about this one. And they said, this is great because this is a lot easier because it asks for 3 things and I have 3 things, right? So what's it ask for? Number 1, starting point. Yes, I got that. Number 2, what's D? Tangent, yeah? So that's the angle, right? And number 3 is the length. Very easy for us to sit there and make that association. And he goes red, and red is never good. And it means data conversion failed from number to vector. And you sit here and you go, oh my God, what does that even mean, right? Because that's usually what comes up. And by the way, as far as errors go, Grasshopper is the nicest one you'll ever see. It's not like it's saying error message 404595, you know, it's actually trying to tell you what's going on. And you'll see this one a lot because data conversion failed from number to vector. Because when you're seeing this, it means that one of the inputs that you gave is not in the right format.
Yeah.
In this situation, some of you shook your heads because you said, when I did the D, you're like, because this guy's asking very clearly for a direction, which is a vector. He also says tangent, right? Line tangent. So there's a lot of confusion just in the English here. It says a direct, so this is what I love about teaching these lessons because it really shows you why it's so important to communicate. D means direction. Direction has the vector emoji. Direction also has the description of line, tangent, parentheses, vector. So if you don't know Grasshopper, you don't know what direction is, a vector, a line, all these different things. So it's really important just to understand that from first principles, the only way that a line can be created from a point and a, I must have hit the, the only way this could be created is using a vector. So that's why some of you right away were saying, that's the problem right there. He is trying, he wants a vector, and we've given him a number. The angle is not the vector, right? So we would actually need, in this situation, still to use some of this script because we didn't actually create our vector that is the vector that we want to have for our line until here. I have no idea what's going on. Hang on, guys. Interesting. Right, so that guy right there, the direction, bang, and now you would have it. Okay? So, to your question, which I guarantee you other people have had, even if they're not going to admit it, this is really a problem of when you start dealing with, when we talk to each other as engineers and architects, we a lot of times will say words. And because we're humans, we're able to kind of understand very easily that if you say angle, I know what you really mean. You mean something that does this, which is really a vector. We don't even think about it. But with a computer, you will spend a lot of time when you're getting started actually with errors like the one that you had that says, listen, sir, I do not know anything about a number for D. D is a vector. Don't give me a number, don't give me a circle, don't give me a point. Oh, by the way, let's do this. If I say construct point, or let's just pull out a point. So we have a point here, yeah? Does anybody know what will happen if I put in a point into vector?
Should be all right.
Well, remember how I said before, and this is the fallacy. Some people say if it's in a computer, if it's green, it means good. If it's red, it means bad, right? Always, right? Let's not forget, the computer is usually wrong. So just because it shows green doesn't mean it's right. And just because it shows red doesn't mean it's wrong. So in this situation here, no one in their right mind would have been thinking, I'm going to put a point into something that's meant for a direction. It doesn't really make sense. So the computer's being clever here for us again. He's converting the XYZ of the point to XYZ of the vector, which has nothing to do with any logical operation that we would consider to be design, right? So again, it's your responsibility to kind of know what's going on here, because otherwise the computer just gives you an answer. There will always be an answer. It's your decision to know if it's right, which is exactly why, again, these tools, I'm just going to pull up the Rhino screen again. These tools like Rhino that allow us, in Grasshopper, that allow us in Rhino to see not only the what of the picture, but the why are just as important. Because if I show this line, and I show this other line, it's in 3D now, but we can obviously tell that something is different here between the solution we had before and the solution we have now. And it's because in one situation, it's complete, it's bollocks. It doesn't make any sense, right? But it still shows a nice, pretty picture, right? So if you were just looking at this, if you're just looking at this one right here, you might think, we got it right, and now we can do stuff. It's not the way it works, okay? Okay, I'm going to finish my loop here. You guys keep working. That's a very, very good thing to ask. Thank you. What was your question? Oh, goodness, yeah.
Is that display is present?
No. So you should have that.
I don't have that. Oh, I want to.
Are you on Rhino 6 then?
No, 5. Your Rhino is also 5.
Oh, but wait, what version of Grasshopper are you on? If you go help, there's Grasshopper about.
0.90005.
Keep that up. I'll just look on mine.
Is that too old?
Maybe. Hang on. Let's see. Yes. So I think you're a few versions behind. That's right. So if you guys are on Rhino 5, just FYI, this is the version that's the latest. Yeah. So that one, the last time it was updated was in 2014. Now recently, I mean, I haven't even. My company's laptop here, I've only recently had the ability to upgrade to Rhino 6. If you have the ability to go to Rhino 6, obviously that's the best thing to do is use the latest one. So if you weren't seeing some of the menus here, maybe just check in help that what version of Rhino you're on, because that might affect what you have and do not have. So if you don't have the latest version of Rhino like me, or at least the latest from Rhino 5, you won't be able to do the display things that I've been showing before.
My one's very late, see? 2009.
2009? That's ancient.
Virgin Thursday.
Is it 0.900076 or?
1.0.0007.
So you're on the latest. So that's the Rhino 6 version.
Yeah, my completely different saying. Work in progress. Oh, my one's 1.0. Decision.
Oh, okay.
一样1.0007嘛，它是0.9，
How do I want to show everybody this?
1.0007，都最新的。
So you have rotate in plane, which you've given a vector, right? So you put this guy. Can you middle mouse wheel? This guy. So go over here. Who's that? He's a vector. Oh, he's rotating. Yes, yeah. Okay, and then this guy right here will have a point actually. He will actually convert it. I'm going to try and recreate this for these guys because this is a good example. Here, I'll just real quick. Okay, we got another good one here. I'm going to try and recreate the situation so we can all see it. There's a couple things going on here. All right. So number one thing is we have the rotate vector command, right? So someone has a rotate vector. So it looks like this. Vector rotate. They also have a rotate in the plane command. We had talked about both of these, yeah? Now, in one situation, we have an x-axis. We have the x-axis going into here, and we have the x-axis going into here, right? And in one situation, we also have the y-axis as the axis of rotation, which is interesting. The angle, we know that I have the angle out here. Let's just do another one. Angle, we know we have to convert those to radians or degrees because they're in radians. Yeah. And this guy's asking for a plane, which she's put in here as the XZ plane. So again, XZ, I can just type it in, it comes up. Okay, let's get Rhino back up involved. So what do we have now? I'm going to delete this guy. So one is giving us a vector, so he has no preview. The other one is giving us a point, because we know that actually he's asking for a piece of geometry. We had talked about this before. And just like I talked about up here, he's being clever for us. He's trying to convert a vector into a point. And then the interesting thing that is almost a natural segue into the next bit that you've done is you've used the Sdl tool. So this same one that we had from up here. And you've actually said, here's my starting point. So starting point out here. And then you've given it this guy, and then you got clever and you said shift select and put in this guy. So far we haven't done this where multiple values go into one input, right? And then if I just put out a length here, I'll have replicated exactly what you have. And that looks like pretty much what you have on your screen right now, right? Let's look at it from the top view, front view maybe. So the question is what's going on here, right? Why does this look this way? So if I show the starting point, that is the way we go, right? So first of all, the direction. Let's show one at a time. Yeah, there's two directions, right? So the component itself has actually done exactly what it can do. It's basically taken in two vectors, as far as he's concerned, one length and one length. So this is one of the golden rules of Grasshopper that I want to share with you. It's perfect timing for this, because so far we've been easily meeting the golden rule of Grasshopper. So let me just, pull this up. The golden rule of Grasshopper. Grasshopper, and remember this, is always a one-to-one operator, or it's a one-to-many operator. Okay? Because we put into these things lists. So far we've been lucky. We've put in one thing in each one of the ABC inputs. So there hasn't been any issue with this. But in this situation, in one input we put in two things. In the rest of the inputs we put in one thing. So it's had to do a little bit of decision. It says, I need to basically apply this guy to all of these guys, right? So when you start putting in multiple things into one component, you have to be concerned about, is it going to be one-to-one? Or will it be kind of like what I've shown here on the right, which is showing basically, hey, listen, I can do one-to-one, I can do one-to-one, but now on this last one, what do? One-to-one and stop? No, I probably do one-to-many. That's the way it operates by default. So what this means for you guys is, in this situation, that's why he said, for this one starting point, I'm going to draw two lines that are based off of these two vectors, both of them the same length. So the reason that this isn't showing it correctly is just kind of what we talked about before, where in this situation, this vector, if I just show this one, this vector is logically not going to be the same as this vector, period. That's why they look different. Why? Because in one case, you have taken this x information here, and you've rotated him in the xz plane 35 degrees. On this one, you've taken a vector and you've rotated it about another vector. So in one situation, you took a vector, you converted it to a point, and then you converted took that point back to a vector. In this case, you've stayed vectors all the way. So it's not the same operation. So if we actually were to sort of, let's see here, how should I do this? First of all, you started with x, right? So this guy is a point at 1, 0, 0. So he just converted this to a point, and then he rotated it. So this is what we're seeing on the screen right now is the output, right? So if I just do, this guy's a point, and then if I take him, this guy is a vector, no preview, this guy is a point. So he converted the point. So if you see that right there, he doesn't show you this. This guy only shows you what he ended up with, right? But this guy is a vector that you just converted to this point, and you did that with it. Now, you say, well, then how on earth did I end up with this line right here, right? That's a good question. So if we look, the starting point's over here. The length is no big deal. So if we look at these guys, we're moving in the z direction 0.57 and in the x direction 0.81, which is exactly why we see it kind of doing like this, right? Because, again, just looking at it, this guy right here, you know, what we've done here between these two means absolutely nothing when it comes to that line. Because you've done almost an unnatural operation. We don't necessarily take points apart and turn them into vectors. So that's why this particular one, again, I wouldn't do this. I think this is the, the data is getting messed up as part of this process. Whereas this one, so you have the x vector, because you had said, I want to take it from the x-axis. You rotated it about the y, because you're working in the xz plane, and you did it by 35 degrees. So that comes out to be something like this. Question is, why is it looking, is that the right picture? Is that the picture you want? So there was a couple things going on here. One was you were putting two things into one, right? The other thing is were you confused about this picture? Is this picture what you expected to see? Is that the right 35-degree angle that we were looking for?
Yeah, when you said x 35 is clockwise, anti-clockwise.
Yeah, everybody, I think that would be surprising to me, is this one, we're looking on plan here, XZ. We would have thought, to be honest with you, I can understand why you thought this is kind of strange, because actually, this one looks more correct, right?
The symmetry to the
Yes, symmetric. I mean, one is anti-clockwise, the other one is clockwise. So,
Yeah, and what's interesting here is this vector rotate. So he says rotate about an axis, right? So the y-axis here, it must be, I mean, x cross z means the y-axis positive should be coming out of the page here. So you would think that positive rotation would be this way. Apparently that's not what's happening here, because you've given it, well, we've given it positive y, and it's rotating it about that axis. Yeah. Yeah, so something funky is going on here that makes it kind of go the wrong direction in terms of that. And at the same time, this guy, again, is seemingly working the right way. So in the XZ plane, rotating positive 35, this point right here is seemingly working. But again, rotating it, are you getting this on purpose? Not really, because this point right here just happens to be kind of at 100, and when you rotate it in that plane 35 degrees, it goes the right way. So, to be honest with you, it's right, but for the wrong reasons. Like, we need to be able to explain it, or else we can get wrong results. So we can also use our fancy tool here, which some of us may have, to say, is that the right business there? We can also do, where is it? This is another one. So angle center point, in this case, would be the starting point. Yeah, so where's my starting point? Angle, end of angle first direction is this point, I think. And if I get the end points out, I'll just explain this in a minute. Just want to see if it works.
oh, it's a good angle.
Yeah, so we now have shown we can preview this. We can see the x-axis is horizontal. So is this correct? See why these tools are important? Because it looks correct just kind of quickly, but when it really comes down to it, that's actually not a 35-degree angle. Ooh, look, now we can really see it, right? If I go with this one right here, this direction, that's a 41.5. What on earth is going on here? Right?
It looks like it's X.
Oh, did anybody see? The problem is I'm still connected to this stream right here, right? So I should be connected to this, yeah? So X, sorry. Yeah, that's fine. What's my end point looking like? So let's just see which point is which. So I'm going to take this guy. Ah, there you go. Which one's the end point? That's the end point, yeah? So that's fine. The first point, that's fine, because it's converted it to 100. 41.3. It's clearly stating 40 right here, yeah?
Is it because it's not really XY plane? Maybe there's a Z.
XZ plane, maybe, yeah? So let's just, it's an interesting problem. So let's see. Let's create a line whose start point is definitely going along the x-axis, yeah? Whose length is the same as the other one, and whose direction is x, and his start point is the same, right? So boom and boom. Yeah? Both of these guys is endpoints, so the center of both of those is the start point, so that's where the angle is starting from. And the end point, if I just get another end point going on here, is we take the angles from, just to be 100% clear. Okay, I think I screwed something up in terms of, again, we've fallen victim to, before this wasn't working, but it's because I was using this. Funny, right? It's the same problem you're having, right? So this is 1, 0, 0, right? At least is what it says right there. So if I put out PT, point, what I can do is I can convert this vector into a point. Visually, that looks exactly right. If we did an angle between, we just saw it, we do an angle between this line and this line, we get 40 degrees. But if I use this point instead of this point, right, one gives me 41.3, the other one gives me 40. So mathematically, I'm not really in control. The issue here is the conversion of this guy into something that we think should work, right? We think this should work, is actually potentially not right. I don't know how to explain that. I mean, my guess is down, deep down, when it does the conversion, we lose some accuracy. But again, we shouldn't be taking vectors and converting them to points necessarily. Sure, we can do exactly, like, this is what we want to see, right? This is exactly what we were hoping the whole time to be able to see. In fact, where's that rotation? So really, whereas you start to get struggling with when you first start is, let's be very clear, I have a vector, and what is it going to? The computer will automatically try and help you, but you have to be the one who says, whoa, 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 whoa. That doesn't make logical sense. I've never seen that before personally, because normally I don't try and take vectors and convert them to points and let the computer do the thinking for me. So for you guys right now, I think that's the main thing, is just keep that in mind as you go forward. And by the way, the more important than anything here today is, if you take one thing away from today's tutorial here, do not forget that these tools are the most important thing. That these tools will allow you to know if the answer is right or is it wrong. It's kind of like when you start working, if you bring someone a drawing and you're sketching around this drawing and they say, is this to scale? You never want to be, as a graduate architect or engineer, bringing something to a meeting that isn't to scale, for instance, and everybody starts sketching on it and taking it for granted. It looks really bad, like it's a basic thing. Same thing here. If we're sitting here and we said, this is the tool that we want something that does this type of an operation, it would be really bad if I show at the beginning of this that I have a 41-degree angle, but really, and it looks kind of like a 41-degree angle, but actually it's something that's like a 39-degree because there's something wrong. That's just not good. It's something that can be avoidable. So this instills a lot of trust when you see something like this. And if I see someone, like I said, if someone comes to me and says, I want an internship or something like that, and they do a little computational script for me, if I see them doing this, hired right away. Clear as mud. There's only one way to learn Grasshopper, and that's with little starting point like this, and practice, 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 keep trying, keep trying. There's no book. Obviously,